guru AYU mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Indah berbalam si awan petang, berarak di celah pepohon ara. Pemanis kalam selamat datang. Awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat petang dan salam Malaysia Madani. Saya Cikgu Hasnitah dari Akademi Youtuber mengucapkan selamat datang kepada semua guru-guru, para murid, ibu bapa dan sesiapa juga yang sedang mengikuti kelas tuisyen online percuma yang kita bawakan secara langsung pada petang ini. Kelas tuisyen kita dibawakan oleh Akademi Youtuber secara langsung dari dua channel pada petang ini, iaitu channel presenter kita Mr.Peh KH dan channel saya sendiri Cikgu Hasnitah. Jadi jangan lupa subscribe channel presenter kita untuk memberi sokongan kepada beliau. Kelas ini juga turut dikuasakan oleh E-Didik Malaysia dan Kelab Guru Malaysia. InsyaAllah kita akan bersiaran selama lebih kurang 1 jam. Jadi semoga apa yang bakal kami bawakan nanti akan memberi manfaat kepada anda. Jadi sebelum cikgu teruskan dengan lebih lanjut, ayo kita mulakan kelas kita pada petang ini dengan bacaan umul kitab dan doa belajar bagi yang beragama Islam. Dan bagi yang bukan Muslim, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin. Jadi kita perkenalkan dulu presenter kita pada petang ini, tidak lain dan tidak bukan, iaitu Cikgu Peh KH dari Kolej Tingkatan 6 Tun Fatimah Melaka atau lebih dikenali sebagai Mr.Peh. Apa khabar Mr.Peh?
Baik.
Okey, cuaca di Melaka baik petang ni?
Sudah mau heavy rain rasa.
Oh ya sudah. Okey, di Penang ni agak cerah tapi menuju ke petang akan beransur mendung lah dan selalunya akan hujan di lewat petang. Jadi kita harap apa jua keadaan cuaca di sana, anda setia bersama kami mengikuti kelas ini daripada awal hinggalah ke hujungnya. Jadi apakah tajuk kelas kita pada petang ini? Kita masih lagi di bab 5 untuk tingkatan 4, iaitu tajuk kita pada petang ini 5.5 Diffraction of Wave. So bagi murid-murid yang akan menduduki SPM, ini adalah peluang yang terbaik untuk anda sebagai latihan ulang kaji. Mungkin ada yang sekarang ini masih lagi menduduki percubaan Mr.Peh. Macam sekolah saya pun belum habis lagi, minggu hadapan baru tamat pada 1 November. Mungkin ada juga yang telah lepas paper fizik, tapi tidak mengapa, kita teruskan masa-masa yang ada ini sebelum kita menuju ke peperiksaan bertulis yang akan bermula pada 30 Januari nanti. Jadi saya tak mahu membuang begitu banyak masa. Presenter kita pun telah bersedia, jadi saya persilakan dan menjemput Mr.Peh untuk memulakan kelas pada petang ini. Silakan Mr.Peh.
Okay, hello, salam sejahtera dan good afternoon everyone. Okay, so okay, I'm Mr.Peh. Okay, so currently I'm teaching at College Tingkatan 6 Tun Fatimah Melaka. Okay, as mentioned by moderator, today we are going to continue our chapter 5. So we are at subtopic 5.5, diffraction of the wave. So total you are going to learn about 4 learning standards today. Okay, so you may download my worksheet for today's lesson with the link shown here. Okay, so as usual for this week we still have 2 classes of the physics for all of you. Okay, so the class for form 5 will be as usual at Friday 9:30 p.m. p.m. Okay, so the lesson for Form 5 is until subtopic 6.2, the Naga Nuclear, and presented by teachers Selenda Nordin. Okay, then for class Form 4 will be as usual like today, okay, on Sunday, 3:30 p.m. Okay, so as mentioned just now, we are going to have about 4 learning standards for today's subtopic. So for the first learning standard, you are going to learn, okay, and you must able to describe the diffraction of the wave from the following aspect. So here we have the wavelength, frequency, speed, amplitude, direction, propagation of the wave, and pattern of the wave. And the second learning standard will be you need to determine the factor affecting the diffraction of the wave. So the factor will be affecting especially the pattern of the wave and also the amplitude of the diffracted wave. So we want to see what is the factor will be affecting the characteristic changes at learning standard 1. Okay, and then for learning standard 3, you need to know how to draw the diagram to show the pattern of the diffraction of the water and also the effect of diffraction of the light. So these 3 learning standards will be combined and discussed now. Okay, so firstly, you need to know the definition of the diffraction of the wave. Okay, so the diffraction of the wave can be defined as the spreading of the wave when the wave propagates through a gap, or we can use slits or obstacle. Okay, so you may look at the figure here. Okay, so when the incident wave hit the obstacle, so this is an obstacle. Okay, so you can see there is a shadow region will be obtained. Okay, while when the incident wave hits the gap or the slit, so the diffracted wave will change the pattern to become circular. Okay, so basically this is 2 effect of the incident wave when hits a gap or obstacle. Okay, so the factors affect the pattern of the diffraction. So the first will be you want to see the effect of the size of the gap or obstacle with the fixed wavelength. So the effect of the diffraction is obvious if the size of the gap or the obstacle is small. Okay, so first, let's look at the effect for the narrow gap or the obstacle. So we expected the large diffracted effect. Okay, so what is the large diffraction effect here? So you can see here will be the incident wave when hit a small gap. So now we discuss about the narrow gap. Okay, so you can see the circular diffracted wave is formed. Okay, so you can see the wave are circular and appear to originated from the small gaps, and spreading of the wave is more significant. So more significant here, you can observe the shape becomes circular. Secondly, the direction propagation is changed from one direction to many. So you can see to many directions. Okay, so this is the meanings of the large diffraction effect to the gap here. Okay, then how about the pattern for the diffracted wave when passing through a small gap? Okay, you can see the wave front merge closer to the obstacle. So you can see here, there is a shadow region. Okay, we call it shadow region, like a triangle here. Okay, so for the smaller gap, so the diffraction effect will be, you can see the shadow effect is smaller, where it will be closer to the obstacle. Okay. Okay, so then now let us look at the effect, diffraction effect for the wider gap or bigger obstacle. Okay, so you can see the diffracted wave is not curved, not circular as we expected. Okay, so the wave bend only at the edge after passing through the gap. So direction is not as wider as the narrow gap. Okay, so you can see a narrow gap, the arrow or the direction is spreading to many directions. But for the wider gap, the spreading effect is less significant. Okay. Then for the big obstacle, so you can see the triangle shape, or we know as a shadow region, is actually larger. Okay, so the wave front merge further. So you can see further, the distance is further. This is closer. Okay, so this is the appearance for the diffracted wave when passing through a wide gap or obstacle. Okay, then the second, we want to see the effect of the wavelength of the incidence wave with the fixed gap size. Okay, just now we discussed about the gap size and size of the obstacle. So the smaller gap and smaller obstacle given obvious diffracted effect, where the diffracted wave will be changed to many directions. Second, the shape or the pattern of the diffracted wave is more circular. Okay, so for this, you can see the first diagram here. Okay, so this one, the wavelength is smaller. Okay, so the effect of the diffraction is obvious if the wavelength is large enough. So you can see here we have the two figures, example A and B here. So A, the wavelength of the incident wave is smaller. So you can see the effect of the diffracted wave here will be not circular. Okay, then the direction spreading also not bigger as B here. Okay, so you can see B, the wavelength is bigger. So we expected the diffracted wave given more obvious diffraction effect, where the diffracted wave will be more curvier, then the direction will be spreading to more wider area. Okay. Okay, so here, shorter wavelength of the incident wave, where showing by the lambda 1 here, okay, is given the small diffraction effect. Okay, so you can see, as I mentioned just now, okay, so the diffracted wave is less curvier. Okay, and then the direction propagation is not as wider as the larger incident wavelength here. Okay. Okay, then for the bigger wavelength of the incident wave will be given obvious diffraction effect. So where you can see the diffracted wave here, the pattern is more curvier. Second will be spreading to wider region. Okay, so however, you can see in these two diagrams, so the incident wave and the diffracted wave, the wavelength is the same. If the incident wave have a smaller wavelength, so the diffracted wave will be given the same wavelength. Okay, later on we'll discuss the characteristic changes for the diffracted wave. Okay, then for the figure B here, so you can see the incident wavelength is bigger, so the diffracted wavelength is also bigger. So both of this is actually equal lah. So that means that the diffraction, for diffraction, the wavelength will be unchanged. And then we look at the third factor. So the effect of the wavelength, again, the effect here we study the difference of the incident wavelength. Okay, so you can see here we discuss the diffracted wave pattern with the fixed edge obstacle. So now you can see the incident wave hit the edge of the obstacle. Okay, so here we have two different wavelength of the incident wave. So at the top one, A, so the incident wavelength is smaller, while the second picture here, B, so the wavelength is bigger. Okay, so here you can see from the dashed line, there is an angle comparison for the shorter wavelength. So we're using theta 1, and then for the bottom figure, we're using theta 2. So from here, you can see very obvious. So the theta 2 is greater than theta 1. So we can conclude that from this figure. So the bigger or longer incident wavelength, so the angle diffracted will be greater. Okay, so let us look at the detail. Okay, so you can see the effect. Okay, so the effect of the diffraction of the wave can be expressed in the term of the angle. So what I mentioned, theta 1 and theta 2 here. Okay, so which refer to how much the wave is spreading out. So you can conclude that with the bigger or longer wavelength, so the spread out effect is greater, where can be showing by the theta 2 here. Okay, so a wave with longer wavelength experiences greater and clearer diffraction effect than that with the shorter wavelength. So you can see at the figure above, shorter wavelength, so the angle theta 1 is smaller, so we spread out less than the bigger or longer incident wavelength here. Okay, so as I mentioned just now, so from the top figure A here, so shorter wavelength of the incident wave will be given small diffraction effect, so where the spreading angle is smaller. Okay, so diffracted wave spread out with smaller angle. Then the second picture, B here, so longer wavelength of the incident wave will be given larger diffraction effect. Okay, where the diffracted wave will be spreading out with bigger angle. So as a conclusion here, basically actually there are two effect or factor will be affecting the pattern of the wave, diffracted wave. Okay, so they will be more obvious for the diffraction effect if the incident wave hit the smaller gap or obstacle. Okay, and the wavelength of the incident should be longer. Okay, so for the incident, for the diffraction to occur, so the wavelength of the incident wave must be at least the size of the opening of aperture of the gap. Okay. Okay, so now let us discuss about the characteristic of the diffracted wave. And this one is actually, you may follow the procedure stated at your textbook. Okay, so this is actually the activity 5.15a at your textbook page 202. Okay, so basically we using the paper tank, okay, so to study the characteristic of the diffracted wave here. Okay, so again, the procedure will be operating for the paper tank will be the same as the activity you already learned at 5.3 and 5.4. So, okay, so firstly, you need to switch on your motor. So the motor will be adjusted the frequency and causes the vibrating bar vibrate. So the plane wave will be formed. Okay, then we want to see the effect of the diffracted wave after pass through the aperture slit here will be the gap lah. Okay, and then you need to spin your stroboscope. Okay, make sure the speed of your stroboscope is moving at the same frequency as the plane wave created by the vibrating bar. Okay, so you observe the plane, you observe the white paper for the shadow form on the white paper. Okay, so if the frequency for the stroboscope you turn is same as the frequency of the water wave, so you may see the fringe image. Okay, so basically it will be like this. Okay, so you can see when the plane wave hit the opening, okay, or the gap here, so the circular diffracted wave will be formed. Okay, so the fringe image will be almost like this lah, but will be very fast one lah. Okay, few seconds you can observe only lah. So you can see the incident wave, the wavelength will be almost same as the diffracted wavelength. Okay, so you can see this is a list of the characteristic we want to study through this experiment. Okay, so basically we want to see the wavelength. So the wavelength for the incident wave, as I mentioned just now, they will be unchanged. Okay, so the wavelength will be unchanged because same depth and the speed unchanged. Okay, so the depth of the water for whole ripple tank will be the same. So they will be not affecting the wavelength. So this one will be already discussed at refraction of the wave. Okay, 5.4. Okay, then the frequency here will be actually also unchanged lah. Okay, because the wave it come from the same source here, so will be from the frequency of the motor. Okay, then the speed will be also unchanged because the speed of the water wave will be changed if the depth will be changed, where you learn already at subtopic 5.4 also. Okay, so the direction will be changed. So it will be from one direction change to many direction. Okay, depends on the gap size. So if the size is smaller, so they will be spreading more wider region. Okay, and then for the energy and amplitude, okay, so this one we need to observe the amplitude of the wave. So you can look at this figure. So the incident wave, you can see here the water will be more chopping, so it will be higher amplitude. Okay, when pass through the gap, so you can see the water is calmer, so the amplitude is smaller after passing through the gap. Okay, so this is because the energy is decreases when the incident wave pass through the gap and form the diffracted wave. Okay, so the energy is decreases because the energy is spreading. So this one causes the amplitude of the diffracted wave decreases. Okay, so because the wave spread out to larger region. So far, this is the 6 characteristic you will be observed through the activity 5.15a at your textbook. Okay, after that, you need to know how to draw the diffracted wave. Okay, so basically, this is an incident wave. Okay, first step, draw the direction of incident wave. So as I mentioned, will be one direction. Then second step, draw the direction of the diffracted wave. Okay, so if the gap is small enough, which is smaller than the incident wavelength of the incident wave, so they will be spreading wider to all directions. Okay, then you have to draw the wave front. Okay, so it will be basically like this. Okay, then the most important part here will be check the characteristic of the diffracted wave. So where the wavelength of the diffracted wave lambda 2 here must be same as the wavelength at the incident wave. So this is what you need to take note here. Okay, make sure both wavelength is the same. Okay, so here we are going to have a practice, okay, to draw the diffracted wave after passing through the gap. Okay, so as I mentioned just now, the first you need to draw the incident wave direction here. Okay, so pass through the gap. Okay, so from A and B here, so both is actually the incident wave hit the gap. The difference here will be smaller gap and bigger gap here. So for the smaller gap, so the spreading direction will be wider. Okay, so the wave will be more circular. So it will be like this. So you must make sure the wavelength you draw for the refracted wave must be same as incident wavelength here. So it will be roughly like this lah. So 3 line is actually enough already. So make sure the wavelength for incident and the refracted wave must be the same. Okay, then for the second, so when the gap is bigger, okay, so the diffraction effect will be less significant. So the spreading is actually limited to smaller region. Okay. So will be here. Like this. So again, make sure the diffracted wave, the wavelength is same as the incident wavelength. So it'll be about this. Okay, so make sure both wavelength is the same. Okay, however, if during the exam, there is only one figure, please draw circular effect. Okay, if I say there is only one figure, for sure that we want to see the diffracted effect is an obvious one. If I say there is only one figure and not mention the small gap or big gap at the question. Okay. Okay, then the second will be C and D here is hit to the different size of the obstacle. So as per mentioned just now, for the smaller gap, so we have the obvious diffraction effect. So the shadow region, the triangle is smaller. Okay, so here will be bigger lah. Okay, so it will be bigger. The shadow region is bigger. This one you can see actually is smaller. Smaller and will be much closer to the obstacle. Oh, you can see this is a different. Okay, and then Okay, so this one, here we merge longer distance. Okay, so make sure the wavelength here will be the same also lah. Because the diffraction effect, the wavelength is unchanged lah. The wavelength size. Okay, sorry. Okay, this one correct. Sorry, I didn't erase it. Okay. So bigger shadow. Okay. Okay, we'll be almost like this now. Make sure the wavelength is almost the same now. Okay, then this one, the shadow region is smaller. So they will be much closer to the gap. Okay, so make sure the size of the wavelength, incident and the diffracted wave must be the same. Okay, then this one, hitting the edge will be given angle here, right? Will be go to this direction. So it's actually upper part here. Oh, it's actually here. Okay, so you have to draw. Make sure again the wavelength for the diffracted wave must be same as the wavelength of the incident wave here. Okay, so this is the way how you draw the diffracted wave for different situation here. Okay. Okay, then now we have already finished discuss about the diffraction of the water. So we still have two type of the wave here. So will be light wave and also the sound wave here. Okay, so now we go to the diffraction of the light wave. Okay, so this is basically the setup arrangement you may get from your textbook also. And the activity 5.515B, page 203. Okay, so the aim is to show the diffraction of the light. Okay, so procedure will be like this. Set up the apparatus shown in the figure. Use a single wider. This one is will be using the wider gap, wider slit. So it'll be just like the figure. Okay, direct the laser light ray through the single slit. Okay, will be here. You see the laser pen pass through the slit. Okay, and then you need to also the screen. Okay, and then draw the pattern in the table. So table will be this. So there will be four changes here. So first will be using wide slit. So it will be the bigger gap. So if I say just now we discussed already, you understand. So the bigger gap will be showing less significant diffraction effect. Okay, so basically you can see the middle part will be wider lah, for the wider slit, and then the effect is not significant because you can see the black, the dark and the bright fringes here is not many lah. Later on I show you the narrow slit. Okay, so third, you need to repeat step 1 and 2 and change the slit size to narrow. So the narrow slit will be given the more obvious or significant diffraction effect. So it will be like this. So you can see the middle part, the bright fringe is smaller because the opening is smaller. However, you can see the bright and the dark fringes is more. Okay, so this one showing that the narrow slit given more significant diffraction effect. Okay, and then the experiment will be repeated and be changed to large pinhole. So this one, these parts will be replaced with a pinhole. Okay. Okay, so what you may observe will be basically like this lah. So there is a circle, bright circle at the middle. So it's a bright fringes, and then will be repeated with the dark and the bright fringes. Okay, and then we change to the small pinhole. Okay, so you see the dark and bright fringes form is more compared to the large pinhole. So that means that with the small pinhole, the diffraction of the light will be more obvious. Okay, for the narrow slit and also the small pinhole here. Okay, so this is just a reference result for you. Okay, so just now I mentioned to you already lah. So you can see for all of the observation, they will have the bright fringes and the black fringes. Okay, for the wide slit, narrow slit also lah. Just the numbers of the dark and the bright fringes will be more for the narrow slit and also for the small pinhole. Okay, so here we can conclude that the diffraction will be more obvious for the light when the slit or the pinhole is smaller. Okay, so the first discussion here, so diffraction of the light wave occur when the light wave passes through a small slit and the small pinhole here lah. Okay, so where you can see from the result I'm showing you here, so the narrow slit and the small pinhole given more bright fringes and dark fringes, which is showing that this is a more obvious diffraction effect. Okay, the white middle bright fringes show that the light wave have diffracted through a white slit. So for this case lah. Okay. So however, if I say the slit is too big, the size, so the diffraction of the light may not be occur. Okay, because the wavelength of the light is very small. Okay, so they will be quite difficult for the light wave to diffract. So we must ensure that the slit size must be smaller than the wavelength of the light. Okay, so if the slit is wider, okay, if the slit become wider, diffraction pattern become less obvious. Okay, where is showing by these two observation for the wide slits and also for the large pinhole here. Okay, then number 4, light wave has shortest wavelength compared to water and sound wave. So therefore, to diffract light, the gap need to be extremely small. Okay, so the maximum diffraction occur when the size of the gap is smaller or about the same size of the wavelength. So for diffraction, or light to occur, so you must make sure that the opening of the slits, the size must be at least need to be equal to the wavelength of the light. Okay. Okay, then now we go to the diffraction of the sound wave. Okay, so here we have this one situation. Okay, so diagrams show a boy is approaching towards the corner. So we here. A radio is placed on other's corner of the wall and beyond his vision. Okay. So the boy is able to hear the sound of the radio before he reaches the corner of the wall. Okay, so why? Okay, as we mentioned just now, the diffraction of the water wave able to occur when the water wave hit the edge of the obstacle. So the corner here is actually acting as the edge of the obstacle also lah. So that means the sound wave will be able to diffracted. Okay, as per mentioned just now, compared to the light wave, the sound wave is actually far longer compared to the light wavelength. So that means here the sound wave will be more easier to diffracted compared to the light wave. Okay, so here you can see the diffraction effect is showing by this figure. So the boy is showing by the black dot here. Okay, so the source of the sound will be from the radio. So the radio give the source of the sound will be hits the corner of the wall and diffracted. And the boy will be able to hear the sound from the radio, although he not reached to the radio here. Okay, so this is because the sound of the radio spread around the corner of the wall due to the diffraction of the sound. Okay, so this one can be imagined like the water wave hit the edge of the obstacle. Okay, so here we have a situation. So a man lying on the back. Okay, this man lying on the back. So he cannot see the television because here we have a wall. Okay, he is actually in the room. So the TV is actually at the living room here. Okay, he cannot see the TV, but he able to hear the sound. So why? So this because, as I mentioned just now, the sound has a much longer wavelength compared to the light. Okay, so the TV will be the source for the sound wave and also the light wave here. Okay, so the man is only able to hear the sound. Okay, this is because the sound wave have a very longer wavelength and more easier to be diffracted. Okay, so when the wavelength increases, the diffraction will be increases. So therefore, sound wave is more easily diffracted if we compare to the light wave here. Okay, so we go to the last learning standard 4. So explain the application of the diffraction of the wave in daily life. Okay, we learned already the diffraction of the water wave, light wave, and also the sound wave. So what is the application in our daily life actually involving the diffraction of the wave? Okay, so here we are going to discuss the application here. So the first will be regarding the water wave. Okay, so you can see here the region of the calm water like beach or seafront. So be at the region B here. So caused by the apartment barrier. So the barrier is actually here. So we build a barrier, okay, so that can prevent big wave from approaching the mainland. So the amplitude at region A, where will be as an incident wave. So the amplitude is very, very high. So the water at A region will be chopping and dangerous. Okay, so we need to build the barrier, which is the obstacle we discussed just now. So when the incident wave hit the obstacle, so the energy will be spreading out. so causes the amplitude of the water wave becomes smaller at the region B. Okay, so the region B, the water will be calmer and suitable for docking the ship, or you want to build the hotel for recreation activity is also better for the safety at the area B here. Okay, so this is the first application. Okay, then the second is application of the light wave. Okay, so if you can see from textbook, okay, so this is a hologram you may see at the credit card. Okay, it will be this bird lah. Okay, so the recording of the hologram on the credit card involve the effect of the diffraction of the light. Okay, so you can see the recording hologram is actually already fixed inside the card. Okay, so in order to reconstruct an image of the object, a light is reflected by the plane surface within the hologram. So the hologram is actually acting as the diffraction grating. Okay, there is an opening and causes the light to be diffracted. Okay, and then you can see the three-dimensional image. Okay, so the image with all of its three-dimensional detail can be viewed by the observer. Okay, so this is the application of the light wave. Okay, then last we go to application of sound wave. Okay, so here the first, so the animals like the whale and elephant produce infrasonic wave to transmit signal at long distance. So what is the infrasonic? So infrasonic wave will be the sound wave where the frequency is less than the 20 hertz. Okay, so 20 to 20 kHz is the audible frequency for human. Okay, so for the sound where the frequency less than 20, we know as the infrasound. Where the sound greater than 20K, we know as the ultrasound. The application we also discussed before for this. Okay, so that means here the elephants and whale here, okay, will be using ultrasound for the communication. Okay, so this is a sound where we cannot hear. Okay, maybe we just can feel the small vibration. Okay. Okay, then the last here will be a radio broadcast using amplitude modulation AM. Okay, can transmitted over greater distance. This radio wave can be received behind a high mountain or building because it undergo diffraction. Okay, so the AM wavelength is actually very long. So as per mentioned just now, for longer wavelength, the wave will be more easier to be diffracted. Okay, so this is limited to the radio wave where they have the longer wavelength. So for the shorter radio wavelength, they will be not easily to be diffracted. So this is limited to longer wavelength. Example here will be AM. Okay, so I think Cikgu Hasnitah, we can take a break first before we go to Q&A.
Okey, baik. Okey, jadi para pelajar jangan ke mana-mana, kita berehat seketika, kembali lagi selepas ini. Okey, kembali lagi bersama saya Cikgu Hasnitah, moderator anda pada petang ini dan presenter kita Mr.Peh KH. Kepada yang baru saja mengikuti siaran ini, anda sedang menyaksikan kelas tuisyen online percuma secara langsung untuk Fizik Tingkatan 4 bagi kelas TLP. Tajuknya 5.5 Diffraction of Wave. Kepada yang bukan murid DLP, anda juga boleh ikuti kelas ini kerana slide Mr.Peh dan bahan yang dikongsikan pada live chat kita adalah dalam dua bahasa. Jadi manfaatkan bahan ini sebaik mungkin. Anda boleh muat turun dan cetak keluar untuk kegunaan ulang kaji anda. Okey, terima kasih Mr.Peh kerana menyediakan latihan untuk petang ini dan sebenarnya ya untuk setiap minggu memang kita sediakan PDF kopi untuk memudahkan para pelajar kita mengikuti kelas ini dengan lebih berkesan. Jadi kita teruskan kelas dengan Mr.Peh. Silakan Mr.Peh.
Okay, so terima kasih Cikgu Hasnitah. Okay, so I just realized that Chakahin is there. Okay, so Chakahin, welcome to my lesson. Okay, so you can join my discussion and show your answer at the chat room. Okay, so for question 2, okay, so this is the objective question. Okay, so total we have about 7 questions. Then the last question will be the 20 marks question and others will be the objective lah. Okay. Okay, so this is a question from past year question 2010. Okay, so the question will be like this on. So diagram 24 shows water wave passing through a gap. Okay, so you can see the gap is here. So here the plane wave is from here, okay, and then will be hits the gap here. Okay, so you can see appearance for the diffracted wave is actually circular. So this one we are very clear that, okay, so the phenomenon for this question will be diffraction. Okay, it's very easy actually. Okay, so here the tips here will be spreading of the wave. So be spreading here the wave through the narrow opening or small obstacle. Okay, so this phenomenon we know as the diffraction. Okay, so we see lah. Okay, so then the next here, question number 3. Okay, so what quantity decreases when a wave propagates through the gap? Okay, so this one we discuss about the characteristic of the diffracted wave. So as per mentioned just now, we have a table. Okay, so the speed, frequency, and the wavelength will be remain the same. Other than that, there will be have changes lah. So for the first, speed will be same, frequency will be same. So the amplitude will be decreases. Then the wavelength will be still maintain the same. So the answer will be C lah here. Okay, then the question 4 is also one of the question from 2013. Okay, so this is the question. Okay, so which diffraction pattern is correct when wave pass through an obstacle? Okay, so just now we have do a practice. Okay, at question number 1. Okay, so from here we need to see the reflected wave. The wavelength must be same as the incident wave. So from here we are clear that the first is almost the same, is it? The first, okay, will be almost the same. Okay, but C you can see is smaller. So this one it will be out already. So other than that, A, B, D, the incident wavelength will be almost the same here. Okay, and then second, we have to see the pattern. The pattern after the incident wave hits the side of the obstacle here. So here she will be moving here direction, right? Okay, so we are quite confident that answer will be D lah. Okay, so here the tips will be first, in the diffraction of the wave, the wavelength of the diffracted wave remain the same. Okay, just now I discussed already. Second, okay, so this is example for the incident wave hits the obstacle. Okay, so you can see here we have the shadow region. Okay, because the direction moving of the refracted wave is here and here, right? Okay, so you may imagine will be just like the bottom part. So direction will be go up. So we form the effect like D here. Okay, so answer here will be D lah. Okay, and then the next will be question number 5. Okay, example question from 2014. Okay, so diagram 22 shows a water wave propagating through a small gap. Okay, so we're passing through here. So expected will be circular pattern. Okay, so which property of the diffracted wave is correct? Okay, so again, we study about the characteristic of the diffracted wave. So again, frequency, wavelength, and speed will be remain unchanged. Okay, so the changes here will be the direction will be from one direction to many. Then the amplitude will be from higher amplitude to smaller because of the spreading of the wave or spreading of the energy here. Okay, so here A, the amplitude is decreased. So answer should be this lah. Okay, then the B, you see the wavelength is decreased, it's wrong already. Should be equal. Speed, equal. Frequency is also equal. Okay, so answer will be A. Okay, then for the question number 6. Okay, so diagram 19 shows a wave barrier. Okay, so the barrier will be here. So we have an opening here. So diagram 19 shows a wave barrier. So what is the function of the gap? So this is a diffraction effect. Okay, we want to ensure that the area close to the jetty here, the wave will be calmer. Okay, will be more safe for the user at this area now. Okay, so to reduce the wavelength, again, this one we study about the characteristic lah. So for diffraction, the wavelength will be same. So the speed of the wave also will be the same. Okay, then the changes here will be to reduce the amplitude lah. Then the frequency will be also the same. Okay, so answer we are quite clear will be C also lah. Okay, so again the tips here will be diffraction occur when the wave reaches the gap. So you must know the barrier is actually causes diffraction occur. Okay, so the diffraction will be the characteristic of the diffracted wave will be frequency, wavelength, and the speed will be the same, and then the amplitude will be reduced. So answer is quite clear, C. Okay, then the next will be our last question. The question is from SPM 2005. Okay, so will be quite similar to our current format, which is discussed about the conception and also the multiplication. Okay, so the question will be like this. Okay, so figure 10.1 shows an arrangement of apparatus. Okay, so this is the ripple tank. Just now I also show the figure to you. Okay, which is regarding the activity and textbook 5.15a. Okay, so figure 10.2 show the bright and dark bands. So the bands here is fringes lah. Okay, of the wave pattern formed on the screen. So with this, the screen will be here. So you can see the effect, the shadow on the screen. Okay, when plane wave pass through the narrow and wide gaps. So here, already showing you this is the narrow gap. So you can see the refracted, diffracted wave is actually more curvier compared to the wider gap here. Okay, so we expected more obvious diffracted wave for narrow gap lah. Okay, so this is what you can keep in your mind before you start your question. Okay, so the question number 1 here, we explain how the dark and light bands are formed on the screen. So it'll be like this two figure lah. Okay, so this one, we discussed actually at previous subtopic lah. So this one, you may already know the crest of the wave will be act as a convex lens, where will be converging the light and form a bright bands here or bright fringes for current syllabus. We use the words okay, and then the trough will be act as a concave lens and diverging the light and form the dark band. Okay. Okay, so answer here first, as I mentioned. Okay, so here 4 marks, you need to have 4 points. Okay, so the first point here will be the crest act as a convex lens. Okay, parallel ray from the light from the lamp converging produce bright fringes, or here we're using bands also can. Okay, then second, the trough will be act as the concave lens. So the concave lens will be like this shape. So when light pass through the concave lens, they will be diverging. So and form a dark region. So for the convex will be like this. So when pass through the convex lens, they will be converging. So all the light will be converging. So we form a bright fringes. So this is the first 2 marks. Okay, and then mark 3 and 4, you may draw. Okay, you may draw your mark 1 and mark 2 situation. Okay, so you can see this is the wave, cross section of the wave. So the light from the lamp will be converging at the crest and form bright bands or bright region. Then here will be trough position. So the light here is diverges. So you form the dark bands here. Okay, so this is the reference answer. 4 marks question. And then next will be conception. Okay, so conception question here, 5 marks. Okay, so observe the figure 10.2, compare the wave pattern and the wavelength of the wave before and after. So before, here. Then after will be here. Okay, so this one before, this one after. Okay, we want to see the wave pattern. We want to see wavelength before and after. And then relate the size of the gap to wave pattern and also the wavelength. Okay, total 5 marks. You need to give 5 points. Okay, so first discuss about the wave pattern. So before and after. So before that, you can see for both narrow gap and wide gap, the incident wave is plane wave. Straight line is plane wave. Okay, so before passing through the narrow and wide gaps, plane wavefront can be observed. Or will be B area. I already draw. Okay, and then we want to see after passing through the gap, you can see is changed to circular shape or curvature. Okay. Okay, so after passing through the gap, the wave emerging from the gap and have the circular wavefront. Okay, will be circular. Although the a bigger gap, so it's less curvier lah. However, still curvier compared to plain wave here lah. Okay, so this is the before and after 2 marks for the wave pattern. Then the wavelength, for the wavelength, you can see the wavelength before and after passing through narrow gap are the same. Here and here. Here and here. For both cases, the wavelength before and after will be the same. So this will be the third mark. Then the last will be you need to relate the size of the gap to the wave pattern. So for the wave pattern, for the smaller gap, there will be 4 more curvier diffracted wave. Okay, so when the gap is narrower, the curvature of the bending is more obvious lah. Or you can mention that the diffracted wave is more curvier also can. Okay, then the size of the gap to the wavelength, so they will be not affected. So the size of the gap does not change the wavelength of the water wave. So you can see this is a 5-point answer. So 5 marks here, although here you can see only 4 terms to us. So you must try to find out 5 points here lah. Okay, so this is the reference answer for question number 2 here. Okay, then the next question is asked about the wave phenomenon. For sure that this is very clear will be diffraction lah. Okay, so diffraction of the wave. Then the last, here will be the modification question lah. Okay, so figure 10.3 shows the seashore of the fishing village during the rainy season. Waves are big. Okay, so you can see the wave are big. So this is a wave lah. Okay, so 1 year the wave eroded the seashore, caused the jetty to collapse. Okay, and damage the fishermen's boats. So to prevent similar damage in the future, fishermen suggest building retaining wall. So here will be the barrier lah, the obstacle, or the barrier can be have a small gaps here lah. So the purpose is we want to make the diffraction or wave occur, and the amplitude as the region where closer to the jetty will be calmer and more safer here. Okay. Okay, so make your further suggestion of way to help the fishermen solve their problem. So you must suggest, you should use your knowledge about refraction, diffraction to explain this situation. So refraction you learn already at 5.3, refraction 5.4, and today 5.5. So all the knowledge you learn already, you may able to answer for this question. So the 10 marks question, you need to give at least 5.5, 5 plus 5 answer. So but here you can see we have only 3. So first, design and structure of the retaining wall, location of the new jetty, and then the size of the energy of the wave. Okay, so you need to do your answer in table suggested. Okay, so where we can get 5 plus 5 point here. Okay, so here first we need to discuss the retaining design structure. Okay, so first reference answer here will be concrete structure. Okay, so the retaining wall can be used concrete to build. Why? Because it will be stronger, okay, and not easily to crack. So this is a reference for the first and 2 marks. Then second, so the retaining wall or the barrier here should be has a narrow gap. So the gap size here must be small, so that given more obvious diffraction effect. So when the amplitude will be smaller, because of the spreading of the wave is wider lah. Okay, so here the smaller amplitude of the diffracted wave will be cause the C to become. So this is the answer where we learn actually today's lah. Okay. Then the next here will be also regarding the first modification here. So the retaining wall should be high. Okay, so to ensure no overspill of the wave. Then the second, here the location of the new jetty. Okay, so this one you learned already at the subtopic 5.4. Bay or where? Got two region, right?
Bay or Cape.
Bay or Cape. Yes, thank you, one. Okay, Cikgu Hasnitah. Okay, so you should build at the bay lah. Okay, so if you already follow the lesson where Cikgu Hasnitah teach you last week, okay, you should know. Okay, so you must build at bay. Okay, because the wave is actually diverges at the area. So the energy is spreading. So the wave at the bay is calmer. Okay, so this is the reference answer for you. Then the last one, size of the energy of the wave. So here, the wave energy, okay, so will be related to the explanation just now, is diverges at bay. Okay, so will be the amplitude and the size of the wave are smaller at the bay. Okay, so these 2 points is actually about the subtopic 5.4 lah. Okay, so that's all for my sharing regarding subtopic 5.5 today. Okay, so thank you everyone. So I pass back to moderator, Cikgu Hasnitah.
Alright, okay, thank you very much Mr. Peh for your well sharing. So students who are still with us, I hope you are understand, you have the full understanding on diffraction from what have been shared by Mr. Peh just now with a very vivid explanation and a clear examples. So kita harapkan kelas pada petang ini memberi manfaat kepada semua yang telah menonton. Alhamdulillah kita telah sampai ke penghujungnya, dan sekali lagi cikgu nak ingatkan anda boleh muat turun dan cetak keluar bahan yang dikongsi oleh Mr. Peh dalam format PDF ini, dan bolehlah lengkapkan tempat-tempat kosong dengan jawapan, contoh jawapan yang telah disediakan oleh Mr. Peh tadi, dan itu adalah format ataupun teknik menjawab SPM yang sebenar. Okey, jadi teruskan bersama kami lagi pada minggu hadapan. Kita ada satu siri lagi bersama dengan Mr. Peh, iaitu tajuk yang seterusnya will be 5.6 interference of wave, right? Okay, so 5.6 will be interference of wave. So jangan lupa hari dan sama pada minggu hadapan, hari Ahad pukul 3.30 petang bersama presenter kita sekali lagi Mr. Peh, 5.6 interference of wave. Dan untuk kelas tingkatan 5 pada minggu hadapan kita ada juga kelas pada hari Jumaat pukul 9.30 malam akan disampaikan oleh Cikgu Rina Rashid dengan tajuknya sudah memasuki bab 7.1 itu teori kuantum. Okay, dalam tajuknya quantum physics. Jadi jangan lepaskan peluang ini, teruskan ulang kaji bersama kami. Semoga apa yang kami bawakan akan memberi manfaat kepada semua dan membantu anda dalam persiapan peperiksaan nanti. Jadi ada sedikit pesanan untuk pelajar kita Mr. Peh?
So teruslah bersama kami lah Form 4 dengan Form 5 punya kelas. So semua yang nak buat ulang kaji, jangan lupa kita lah. So kita sentiasa bersedia membantu semua. Okay, thank you.
Okey, jadi teruskan bersama kami. Jadi subscribe channel Mr. Peh sebagai sokongan anda kepada presenter kita pada hari ini, dan insya-Allah kita akan berjumpa lagi dalam masa yang akan datang. Jadi saya selaku moderator memohon ampun menyusul pelajari sekiranya ada sebarang kesilapan ataupun kekurangan dalam kelas ini. Sesungguhnya yang baik daripada Allah, yang kurang itu semua daripada kelemahan dan kedangkalan ilmu saya. Jadi kita jumpa lagi dalam siri yang akan datang. Terima kasih dan bye-bye semua.